Alright, so number 5, again, we'll start off with the the end behavior. So we look at the leading term, which is this one. It's an even power, so this tells you that both ends go up or both of them go down. And so you look at the leading coefficient, which is positive, so that tells you both ends go up. Okay? For the zeros, now this has the quadratic structure. So it's gonna, you're gonna think of it in terms of like x squared minus 9x plus 8. You know how you would factor that. So this you would factor as x minus 8 times x minus quantity of x minus 1. But because the power is 6 and 3, not 2 and 1, when you factor this polynomial, f of x, it's going to equal x to the third minus 8 and x to the third minus 1. So you set each factor equal to 0, and we factor it further, so that's going to give us x minus 2, because it's the cube root of 8 and the cube root of x cubed, that's x minus 2. And then remember, you square the first term, that's x squared. Change the sign, multiply the x and the 2, so that gives you 2x, and then you square the last term, which that gives you 4. Okay, for the next factor, cube root of x cubed is x, cube root of 1 is 1. So you square the first term, that's x squared, change the sign, multiply the 1 and the x, and then square the 1. Okay, so remember, this gives you no real solution. This gives you no real solution. So the only zeros that I have, the real zeros, are 2 and 1. Excuse me. Each have a multiplicity of 1, so that means that the graphs are going to cross on the x-axis at these values. Okay, so the y-intercept is 0, 8. Okay, so let's go ahead and plot this graph. Alright, so you plot what you have. So we have the zeros at 2, 0 and 1, 0. Then we have the y-intercept at 0, 8. We also know that the end behaviors are up, up, so that means that the graph is coming in from the top, so it's going to go this way. Okay, then it crosses the x-axis because the multiplicity is odd. At some point it has to curve back up to go through 2, and then it just continues on. Okay, now how low this goes depends on, you know, I mean, not depends, but you would have to figure it out either with Desmos.com or plug in another number for x, which in this case it would be like 1.5 or something. So I went ahead and I used Desmos, and we got the minimum to be 1.651, negative 12.25. So that's the actual minimum of this function. So that would actually be, let me get the color, 1.65 approximately right here. Approximately. Okay, so notice it's not like 1.5, it's not halfway between these two. There's no symmetry. It's actually lopsided. It's more towards the right side because it's 1.65, negative 12.25. So the graph would look something like this. Kind of like it's coming in from the top, and then it kind of goes more towards the right, and then back up like that. Okay, so let me erase this part. And it would be more like this. Okay, so that's the function for number 5. Alright, so number 6 has a negative leading coefficient and an odd power. So because of the odd degree, the 5, one side is going to go up and the other one down. So the negative tells you that on the right side it's going to go down, and on the left side it's going to go up, like that. Okay, so as you read the graph from left to right, it's coming down. Okay, Now this one has 4 terms. So remember when I told you when in this section, the polynomials that have 4 terms will factor by grouping or with the box method, whichever you want to use. So I'm using the box method and just put them in order in standard form, put them in order from highest degree to lowest, like that. And then you ask yourself, what's the greatest common factor here? And the answer would be x cubed. So that's what comes out, x cubed. And then something times x cubed is negative x to the 5th. So that would be negative x squared. And then something times x cubed is 4x cubed. That would be 4. And then something times negative x squared is negative x squared. That would be 1. So the two factors would be, oh, and again, I almost forgot, you always check. 4 times 1 is 4. So that works out. So f of x equals x cubed plus 1 times a quantity of negative x squared plus 4. So I'm going to factor out a negative just so that this x squared is positive. So I'm going to factor out a negative from there. So it's going to look like this. Like this. X squared minus 4. So here in the first factor I have the sum of 2 cubes, and here I have the difference of 2 squares. So when you factor that, you get x plus 1, and then the second factor for that one would be you square the first number, change the sign, then 1 times x, and then 1 squared. And then the second one, this one right here, is difference of squares, so x plus 2 times x minus 2. Okay, so the zeros here are negative 1, here it's negative 2, and here it's positive 2. This one here gives you no real zeros, right? Okay, so the ones we're going to, and all of them, notice how all of them, the exponent right here is 1. So they all have a multiplicity of 1. So the graph is going to cross here, it's going to cross here, and it's going to cross here. Okay, so we're going to plot the points, the zeros that we have. So negative 1, negative 2, and positive 2. I also know the y-intercept is 0, 4. So notice on the y-axis I counted by 2, so 2, 4, 6, 8, so 4 would be right here. And I'm going to calculate f of 1 just to get another point on the graph. So f of 1 is negative 1 to the 5th, so that's negative 1, plus 4 times 1, that's 4, minus 1, plus 4. Again, I'm using, of course, I'm using the equation up here to find get these numbers right here. So I get negative 2, that's going to give you 6. 8 minus 2 is 6. So I have the point 1, 6 right here. Okay? And so that's enough information to graph what we have. We're coming in from the, on the left side, it's coming in from the top. So we're going to go like this, cross, cross, go over, and cross down. And that's the graph. So remember, polynomials cross the x-axis only at the real zeros, nowhere else. Okay? The multiplicity tells you whether the graph is going to bounce off or cross through. And again, get the y-intercept whenever possible, and then calculate 1 or 2 extra points to get a more accurate curve. Notice I didn't do that right here because there's no integer in between here, and I don't want to deal with the fraction right now. So you plug it into Desmos to get the actual value, like to get that minimum value, and then to get the maximum value up here, you just use Desmos for that. Okay, and that's it.